Time for another draft physics video presentation. A comment related to the subject of the video. Sort of. So what the hell? We'll read it. That isn't helpful. Hi. I say the following with all due respect. Well, whatever. You spend too much time in your videos making fun of other people's usernames, profile pictures, subscriber levels, and so on. I don't think I've ever talked about a subscriber level beyond pointing out that really garbage physics videos have like 1 million views, and I point out, look, this got 1 million views and it's really junky physics. Profile pictures, what percentage is your argument? 0.000 what percent of my videos am I talking about profile pictures or even usernames? What percentage are you arguing here? And it's too much? Just an insanely silly comment, frankly. I mean, I spend so little time, and none of the subject videos have any of that in it anyway. They're the videos I'm sort of promoting. They're the videos I want to see a response to. So anyway, none of this contributes to anything other than the standard online drama. It's a tiny percentage of the videos in the first place, and it is a real drama, for fuck's sake. Okay, when people are calling you outright names, that's drama. Okay, people say I'm wrong, or I'm an idiot, or I'm a moron, or I don't know this, or I don't know that. They're making the accusation, aren't they? Me defending myself is perfectly rational. So what the fuck? Again. And you're showing the world how to do it by not making any videos and not saying anything. So you're some coward who doesn't even play in the real ball game, and you're telling the pros how to play? Oh, I see. This is a shame, as your actual substantial arguments are pretty good. And so you're saying the audience that's supposed to know that can tell the difference, is too stupid to be able to find the good arguments? They can't see them? They can't find them because they're too distracted by the drama? Oh, I think it would be exactly the opposite. I really respect you overall, but just wanted to offer this friendly advice. I just don't know what to do with it. It just makes so little fucking sense. I don't know how to make anything out of it. What do you want me to say? Oh, you're obsessed with this one thing I do? Like if I pulled my hair now and then, did this, and it really annoys you, but it's only like for 10 seconds of the video? And just because I did that, oh fuck, video's ruined for you. You can't watch anything anymore. You can't learn anything. You can't understand anything. Can't argue anything. Can't do anything because you're too distracted by this. Oh yeah, there I did it again. I mean, get real. I mean, I could have like drip, a bad eye or something. It could be oozing goop, and I'd still expect the audience to get over it. Yeah, come on. You're supposed to be able to do that as a human being, is to say, okay, there's parts of these videos I don't really like. Okay, so what? It's a tiny, tiny percentage of the videos. So get over it. Oh, that shouldn't be my response. Oh, well, that's my response, Jerry. Jerry 3, whatever that means. Stupid screen name, by the way. Stupid. It doesn't, instigate in the brain some kind of immediate response where you say, this is a real credible guy. This isn't like one of Donald Trump's sons or something. Yeah, no, this is a really smart guy who's commenting. I should pay attention. No, it doesn't really say that. Jerry 3. Alright, so on to the real subject of the video. God. This guy. Alright, so, all I can say is you try to be reasonable, you try your best, and they're just impenetrably retarded physicists. As a class of human beings, I think they're more than just full of shit. Okay, they're retarded. Okay, they really can't do anything right. Much. Anyway, so, I tried to contact this guy in the most reasonable way possible, made every effort, and the response was so idiotic and so moronic, I have to make it public just to point out that this is what I'm up against. This isn't the first time it happened. Like, if it only happened once, you'd say, okay, it just happened, one guy's an idiot. But I'm telling you, I've had this happen more than once. Okay, the other people don't have public YouTube channels, so I have no reason to out them, as morons. But I mean, it's moronic. They can't do anything, they just. Well, so we'll see what I'm just going to show you. This is what it's like. All right, trying to get somewhere in terms of penetrating their little club of bullshit. Okay, so Dermot, I said. Okay, I have to make that so you can see it. That'll be helpful. So I just have my half of the emails here, but his half is going to be easy for me to paraphrase because it really wasn't his half. Okay, so it was all you all just wasted my time. Dermot. So anyway, I saw his channel. I said, okay, this is like he's an older guy. That's a downside. Okay, they get a little senile and wacky. But they're retired. Essentially, you could argue he's got plenty of free time. Seems like he has plenty of money. Blah 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 blah. So I said, yeah, this is a good guy. Okay, I should be able to get somewhere with this guy. I could get nowhere. All right. I've watched a few of your videos and was generally impressed. I have a YouTube channel called Draft Science where I have over the last 10 years constructed a counter theory to QM and bent spacetime. I believe it answers all questions raised by experimental events more simply and more completely. I would like to test it through conversational interrogation with a real physicist, but unfortunately have found no one willing. I am willing to pay you for your time if you are willing to participate in a recorded conversation regarding the strengths and weaknesses of my model versus the conventional physics. Oh, that was fine. Thank you for your consideration, Gary. So he says back, I don't need payment for anything, and gives me his cell phone number. Great. But you really think I'm just going to call you up any old time, and expect an hour's worth of conversation? That doesn't make much sense, Dermot. Come on. You can figure that out, can't you? Well, anyway. So I responded rationally. Dermot, thank you so much for the reply. I was very grateful. I got a reply. I don't get too many of those. I didn't in any way wish to impose or be any kind of nuisance. I'd like to schedule the timing of conversations completely at your convenience. Regarding subjects, I have been currently studying light interference experiments and believe I can demonstrate that the wave theory doesn't actually work. Oh, yeah. And that conventional physics' whole understanding of photons is incorrect. I recently did an unlisted short 17-minute video to someone else on the subject of the slit experiments and think it covers many of the important points I would like you to address. Here's a link to the video. So I linked to the old video I had done to Franklin Hu, and frankly I made a new one for him, and so I linked him later to the new one. But anyway, that's what I linked to. If you think you would be interested in discussing light theory and the points I raised, let me know when a good time to call is. So I keep reiterating this point that it needs to be an organized conversation because, frankly, your reputation, you're going to be, so it's going to be a recorded conversation. I don't want to confuse you. I don't want to make you look like an idiot. Shit. To be clear, I do intend to record the conversation and upload them to YouTube. If you have a Skype account, I can also include your video in the recordings. Anyway, thanks again. Let me know of any issues or concerns you may have. Best regards, Gary. So what does he send me back 2 weeks later? That's my wrong email. This is my other email. So he sends me an email address. Doesn't respond to any of this. And all of this is in the email he sent me with the corrected email. So it's not like he couldn't read it. It's not like he didn't see it. It's not like it was invisible or something. So this was all in the this was in the email. So all the previous conversation was in the email, and he sends me another email with it to another email address and nothing else. So I resend to that email. And I think, thanks for the corrected email. I would still like to get us to a clear starting point before we talk. I have made this 18-minute video. Okay, so that's the new one that I think is just totally indestructible. And I'll now pay $1,700, right? $1,700. All right, to any channel with 100,000 or more subscribers to play the video on their channel, just 17 minutes, and in some way demonstrate how it's incorrect, how it's junk, it's garbage. $1,700. Okay. Regarding my dissection of the two-slit experiment, I think it well defends my assertion that many of the conclusions of popular physics are incorrect, or at minimum are insufficiently evidenced to be stated conclusively. If you are willing to watch the video and are I say it here, it's willing, to discuss the points made, let me know when would be a good time to call and discuss the issues. So, can't be any clearer. And he sends me this crap. Okay, it's a link to a little tiny clip of Feynman's, just a tiny, one minute long clip, right? And he just copied the text from the description on the video. So he sends me this crap. Richard Feynman is an American physicist and one of the greatest explainer, and one of the great explainer. It's not even written well. Okay, in this video he is delivering his lectures about double slit and cornerstone of quantum mechanics, and showed how electrons behave as both particle and a wave. I mean, it's a stupid description, actually. So, yeah, this is the video. So we'll go to the video. And then we'll play the real Feynman video, right? That would be the sensible thing for me to do in response to this. It's nothing, this bullshit. I mean, just totally ignore everything I asked, everything I said, and just respond with a silly piece of propaganda that I've already dissected in videos pointing out how it's just so full of idiotic mistakes. I mean, there were idiotic mistakes in Feynman's video. I mean, idiotic ones that are so easily pointed out. So that's what we'll do. But I mean, what can you say? This is the best they can do. This is they're showing what great scientists they are. This is how, we could probably find lots of letters by Newton and all the famous physicists of the Rutherford and all those people. There's lots of letters where they're telling people, hey, fuck off. Don't bother mailing any letters to me. Where they're just doing this kind of horse. I don't want to have a conversation with you. Newton's right about everything. Fuck you. The end. I mean, this is just such bullshit. All right. So let's play this one little clip just because it's funny in itself. But I mean, and it's not even good quality, So anyway.
Therefore, it's impossible to have an information ahead of time as to which hole it's going to go through when the light is out, or when the light is on, or out, in a circumstance.
So when he says the light is on or out, he's talking about a detector. He's talking about detecting electrons going by shooting light at them. Like this was possible anyway. It's never happened. It didn't happen with electrons, and it certainly didn't happen with photons. So here he is describing an experiment that can't be performed. You can't passively detect an electron, and you certainly can't detect a photon, and everything about his drawing is the photon experiment. He didn't draw the electron experiment because he knew if he did, the audience would say, what the fuck? Right? Because he'd have to put all these funky lenses in and all this bullshit, right? And all these devices. And they'd be like, well, what the fuck? You're not showing me anything, right? So he uses the light experiment as to do the demonstration because it's so dirt simple. But the electron experiment isn't anything like dirt simple. They don't just shoot electrons at a slit. No.
With the experiment is set up there to produce this interference. So it is not a lack of...
So he calls it an interference pattern. Clearly, the interference pattern can only be created by some sort of wave mechanics. So why does he call it an interference pattern when what he wants to call it is a random pattern created by the random God?
Unknown gears, the lack of internal complications that makes nature have probability in it. It seems.
So he's saying there's no cause to the effects. So I'm obviously arguing that what can be easily dissected out of the experiment is that there is a cause. It's called the slits, the surfaces. The surfaces are causing everything, and you can see it in the single slit because most of the light goes straight through. And then when you do the single impediment, you see that, oh, just the fringe light goes through. And the further away I put the impediment, the more light that gets through, the brighter I can make the center, or the less bright I can make the center. I can make the center very, very dim if I bring the impediment closer and closer to the source of the light. So clearly indicating everything about the fringes is being caused by the surfaces. They're completely controlled by the surfaces. Without the surfaces, there is no pattern. That's the clear thing that can be deduced. And he's claiming, no. Each object heading for the slit is somehow uncertain in where it's going to go. No, there's a clear certainty. The ones that go through the middle, they just keep going. Okay, they don't do anything. They do exactly what a laser beam does. It goes straight. It's all about the surfaces. And the double slit proves it because the surfaces end up being critical to the math that works. The only math that works counts the surfaces and recognizes 4-point sources. 4-point sources give you the right answer. 2-point sources give you the wrong answer.
It seems to be in some sense intrinsic. Someone has said it this way: nature herself doesn't know.
So, this is just baby talk, frankly. It's just, oh yeah, because we can't see it, we're just going to pretend we got fooled by the magician, and yeah, he's really pulling pigeons out of his sleeve. There's no, there's no explanation. He makes pigeons. That's all he's doing, is admitting his own failure. I can't figure it out, therefore it must be unfigure-outable because I have such a giant brain. And if I can't tell you how the magician's doing it, nobody ever will be able to, because I'm so great and I'm so powerful. It has to remain a mystery forever.
Which way the electron is going to go.
So again, he drew the photon experiment. So let's not play this game that electrons are the same as photons or the same as minibuses. No, they're not all the same thing. It's just frickin' stupid and idiotic to say they're all, chickens and cats and frogs. Oh, it's all the same thing. No, it's not all the same thing.
A philosopher once said, pompous, it is necessary.
He'll be pompous. I'll pretend to be pompous. As a you have a lot of practice doing that, don't you? Ugh.
Sorry for the very existence of science that the same conditions always produce the same result. Well, they don't.
Okay, so that's his claim, that the same conditions don't produce the same result. So he's just telling you that, no, the dice are magic. So when you go to Las Vegas, it's all magic. There's no physics involved at all. There's no real cause and effect. It's just absolute crap as an answer. It's such an evasion of the simple truth that, no, if I make the same conditions, the thing's going to come out the same. And that's going to be a truth. And none of this experiment does not at all threaten it. All right? And it only threatens it if you cheat. And you lie and you cheat. Okay, because the truth doesn't say that.
Set up the electrons in any way. You set up the circumstance here in the same conditions every time, and you cannot predict behind which.
Yes, well, we cannot predict because it's not the same circumstance every time. Obviously, a device producing photons does not produce photons from exactly the same location and exactly the same timing. So we already know that. So those certainly aren't the same conditions, are they, Richard? No, they're not.
Oh, you'll see the electron.
So this is just the woo part, and it's just fail all over the place, and this is just so depressing. All right, so anyway, I guess I'll move on to the other Feynman video, and we'll just go through some more of it. We'll do it again and again and again, I guess, until people concede that no, this isn't a very good science. It's actually garbage as science. It's like anti-science. It's so bad. It's such a poor demonstration of the scientific method and how to tease the truth out of experiments. You don't do it by propaganda. Alright, so let me pause and find the other Feynman video and blah blah blah. Alright, I'm back. Yeah, so I would just play one of Dermot's videos, but he doesn't have any on subjects relevant to either gravity or photons. So, there aren't any on the specific subjects to be argued. So, I prefer to do that, but until he makes such a video, maybe he will now. Maybe he can make a two-slit video explaining how we must believe the universe is run by a random god of some kind. Yeah, then I can point out how, no, we don't have to believe that. We don't have to be fools and dupes. We don't have to fall for another stupid religion. And that's all this is. It's a stupid religion. Get to it already.
In the beginning of the history of experimental observation or any other kind of observation on scientific things, it's intuition, which is really based on just experience with everyday objects that suggest reasonable...
Right, so intuition is just experience, exactly. So it's experience, period. So how much experience do we have? Do we have books? Do we have acquired knowledge? Other people have done the experiments, all that kind of stuff. That all builds up into a certain knowledge base, and the knowledge base is going to tell you what the right answers are, because it has in it all of these different ways of doing the experiment and different things, and it points out all the details. And you start paying attention to the details, you can get the right answer. So the point is that they never paid any attention to the details of the two-slit experiment. That was clear. Young's drawing doesn't make the right pattern. They're not in the right place. It doesn't work mathematically. I shouldn't be the first person to point that out, but the math doesn't work. You can't draw two waves, with their centers on the openings and get the right pattern. It can't happen. Light doesn't do that. All right, and that's been true for 200 years now. And where's the admission that, well, we shouldn't draw it that way, we shouldn't explain it that way, because it doesn't actually work that way. Waves don't work. So that's what their intuition should say, is that, oh yeah, we when you analyze it, you really look at it and you really take it apart and details. There's no squirrels. Squirrels aren't making the engine run. No, it's pistons and gas pressure. Yeah, lots of other stuff is happening. It doesn't have it. There's no squirrels in there.
Full explanations for things. But as we try to widen and make more consistent our description of what we see, as it gets wider and wider and we see a greater range of phenomena...
Yeah, then you start to make everything into one thing. You do this de Broglie crap, and you start saying electrons are the same as photons, which doesn't make any sense. I mean, electrons are charged. I mean, it's fundamentally different. They don't move the speed of light. I mean, so many things are different about them. Why would I say those two things are the same? And then you say those things are the same as a mockingbird and, platypuses. They're all the same. And elephants. And then I can go up to space shuttles and I can say planets. Planets are the same thing. It's not all the same thing. That would be silly. That's not widening your knowledge. That's being an idiot. Frankly.
The explanations become what we call laws instead of simple explanations. But the one...
So they made these laws, Heisenberg law. It's a principle, but they've turned it into a law now. It must happen. We can't know. We can't do this. And so then they'd say, well, because we can't know in this circumstance, we can't know anything. So we can't know spin, and we can't know entanglement, we can't know this, we can't know that. I mean, all these rules about what we can't know. And they don't even know these things even exist.
What odd characteristic is that they often seem to become more and more unreasonable, and more intuitively far from obvious.
No, well, some of the laws are really good, some of them, but they're still going to be picked apart. I mean, this law that you have to have this conservation of energy. Well, if you understand energy to be movement over time, then you can understand that something can, take some time to move something, and therefore lost a little bit of energy because it had to move something, because it had to pick it up and expend energy to move it from one place to another. And if force is actually moving matter, well, the force is actually using up some of its time. It's moving slower when it's pushing the matter, less is going on while it's pushing the matter, frankly. Less velocity is involved, and therefore something has been lost.
To take an example is the relativity theory, in which, for instance, the proposition is that if you think that two things occur at the same time, that's just a subjective opinion. Someone else could conclude that those two events, one was before the other.
Right, somebody can conclude that, but, well, we know that that doesn't physically have anything to do with the fact that the two things happen simultaneously in space. In the universe, there are things that happen at the same time. And because two humans are in different positions and they disagree about what they saw, you didn't change the facts. So again, they're proposing a theory that somehow the facts have changed. Well, no, you didn't change the fact. The fact is they were a simultaneous event, and all you can do is fuck up looking at them. You can screw up your perception and get the wrong answer because you looked at it wrong. You could look at a platypus from the back end and say it's a fartopus. And you look at it from the front end, you call it a quackapus. You can do lots of stupid things, but it doesn't mean it's the truth. So right there, another pile of mush.
And that simultaneity is merely a subjective.
Yeah, so now he's saying the facts are now subjective. Why are the facts subjective? Why did the universe is not 3 dimensions anymore? There's not real things going around. There's not real things moving. There's not real physical dimensional requirements. All of that can be blown up. Why? Because somebody says so, because somebody says bent space, and all of a sudden it's time, that all of a sudden we don't know that time is a function and it's not a dimension. We have strict rules for what a dimension is. It has to have a right angle to the existing dimensions. If it can't have a right angle to all 3 of the existing dimensions, it can't be a dimension. That's the rule for a dimension. Why are we calling time a dimension? It's not going to have a right angle to any of the other 3 dimensions. It's just bullshit. Silly bullshit. Very silly bullshit.
Impression. Now, there's no reason why this should be otherwise, really. The things of the direct everyday experience involve large numbers of particles, or involve things moving very slowly, or involve other conditions.
Right, so that should give us a clue there, right? That we're watching group behavior. We're not watching individual behavior, right? We don't see one photon. We don't see, one bumblebee or one bee or some other in a swarm of birds or insects or something. We can't do the one thing. We have to do it by a group. We don't interact with other human cells. We interact with billions and billions of cells. So there's lots of group behavior out there, and we generalize about what the individuals do based on what the groups do. And that's fair to do, but I'm just saying you've got to be careful doing that, because that each individual isn't doing exactly the same thing. Some of the fish are swimming that way when the school of fish is going that way. It's just a fact. Some of them are going the wrong way.
That are very special and represent, in fact, a very limited experience with nature. It's a small section only that one gets of natural phenomena from a direct experience. It's only through the...
Well, we can't have direct experience with things that are a zillion times smaller than we are. That's just one of the rules, that it's really hard to do. We don't have instrumentation that allows us to dissect and play with things that are a trillion times smaller than we are. That's just a fact. So we have to deduce it based on what we see as generalized behavior. But again, I could show you generalized behavior over and over of a roulette wheel, and there's no reason for you to sit there and assume, because I can't figure out exactly all the permutations and all the possible bangs and angles and speeds and momentums, that I have some belief that all those rules aren't involved, that all those interactions aren't critical. A little piece of dirt on the ball makes a difference. Little things I could change that would make the outcome come out different. Of course I can figure that out. That of course it is a permutation of reality, and it has its circumstances, and the causes are going to make effects. There's not going to be any other thing that happens. Causes are going to cause effects.
Refined measurements and careful experimentation, that we can get a wider vision. And then we see unexpected things. We see things that are far from what we would guess.
It's not that far, actually, right? So this is, again, we go back to Newton's rings. And yeah, I'm sure everybody was like, whoa, that's really weird. You make the aperture smaller and smaller and the light starts spreading more and more, and it's doing this ring thing. It's kind of bizarre, weird, bizarre, strange. But nobody starts hysterically running for their ostrich hole to stick their head in because they can't deal with it. You don't have to start breaking all cause and effect rules because something does something that surprises you. You pour a little bit of water on some metals and they explode. Why the fuck is it doing that? I mean, it could surprise you, but really, do you start breaking all of the notions of reality because that happens? No.
We see things that are very far from what we could have imagined. And so our imagination is stretched to the utmost, not as in fiction to imagine things which aren't really there, but our imagination is stretched to the utmost just to comprehend those things which are there.
To explain them, that's right, it's complicated. And so if somebody came here, like there were aliens, and they had their own kind of iPhone, it would take a while to figure out what programming language they were using, or what kind of CPU, how the CPU works, and how this works, and how that works. It would take us a while to figure it out. Yeah, sorry, slight interruption. So look, there's lots of giveaways here, right? The single slit in light doesn't look anything like the single slit in water, right? I drop a pebble in water, the water waves go out. They don't interfere with each other. They don't superimpose. They don't do any of this nonsense, right? But I do it in light. All of a sudden, I get the same weird pattern as I get with two slits, right? A little bit different, but same idea. Same functional cause and effect mechanism is at play here. It's just the arrangement is different, but the instrumental cause is the same. There's no way of saying it's a different cause. Professor Lewin will admit this. Okay, you can call it diffraction and then call the other pattern interference, but it doesn't matter. It's all the same thing, the same cause. It's surfaces that are causing it. That's what clearly can be deduced. And they totally ignore that evidence. So he's saying this in some sort of context where they just overtly ignore every signal that's saying you're going down the wrong path. You're going down the wrong path. All right, this isn't a good analogy. This isn't. You're not realizing that an on-off pattern is not secret code that says interference to every brilliant mind in the universe. An on-off pattern says to a brilliant mind, it's the simplest pattern in the universe. I mean, lots of things can make on-off patterns. I have no reason to assume it's a wave. No good reason. So there's absolutely no fair reasoning going on here. This is just propaganda. They want to believe, they want to believe, they want to believe, and that's why they go down this road, and they just ignore all the evidence that's screaming to them, you're jumping to a conclusion, you're jumping to a conclusion, you're jumping to a conclusion. The evidence doesn't really fit. The evidence doesn't really fit. They're just ignoring it.
Yeah. And it's this kind of a situation that I want to talk about tonight.
So we have a puzzle. Yes, we have a pattern created when light is shined through or at surfaces. That's the factual mechanism. A surface. You can do it with one surface. All you need is a surface, and you're going to create some phenomenon. Now, yes, the phenomenon is a lot easier to see if you use 2 or 4 or 10, but it's there.
Start, for instance, with the history of light. At first, light was seen to behave, it would appear to behave very much like a rain of particles, of corpuscles, like rain.
Like rays. The sunlight was drawn as rays coming off the sun. It sort of made sense. Why there were shadows and all that kind of stuff. It all kind of makes sense. Yes, they're rays. And all that's really changed is that we've realized that a tiny fraction of the light, and it is a tiny fraction of the light is actually traveling near the surface. And because we know physics now, we know that the surface isn't made out of milk or coffee or steel or any of that crap. It's made out of electrons and protons. It's made out of complex little funky devices that really don't have any identity as a surface. Okay, that the surface is really, there's molecules of the atmosphere right now digging into you, and there's pieces of you flying off. That's right now, it's happening. Your surface isn't some sort of consistent, flat, smooth thing. And so the understanding was, oh, the light is traveling through a mixed medium, and that medium is causing some of the light to scatter, to fracture, to go in some new direction. And that was totally intuitive and made total sense. But instead of doing that logic, they decided, it's too mysterious, it's too crazy, the photons know we're thinking about them. That they had to go for some wacky, silly story.
Bullets from a gun, same idea. And then with further research...
So I wish they thought about it as bullets from a gun and understood that that's what the frequency is. Okay, the frequency isn't a wavelength. The frequency isn't some artificial piece of crap I'm going to draw. No, the frequency is just the distance between the bullets. That's what the frequency is. And that it really happens over time. That a photon isn't some event that happens, boom, there, photon. No, that a photon is a repeating of an event at a certain frequency, a period of time. And that makes perfect sense.
It was clear that it was not right, but the light actually behaved like waves, like water waves, for instance.
Oh, yes, it doesn't. See, that's the funky, the silly part of this whole conversation. It doesn't behave like water waves. So the single slit proves it. The single pebble dropping in the water proves that it doesn't behave like waves. There is no magical interference unless you have surfaces. And then what you understand is that, yes, if I do the round aperture, I have a whole bunch of surfaces, right? Millions of them, but I also am making the pattern in millions of directions. So that's why it comes out as a ring, and the simple thing is if I make it narrow, if I make it linear, the slit, well, then I can see more clearly that it's bending the light this way on the surfaces. So if it's round, it bends it in all the round little directions. Not that complicated, pretty easy to understand.
And then in the 20th century, on further research, it appeared that light actually behaved in many ways again, like particles. In the photoelectric effect, you could count these particles. They're called photons now.
So again, it's kind of silly to talk about counting the particles of a photon, because really a photon is an event. Okay, it requires certain things to take place that are time related. That you can't talk about it without talking about the frequency, and then talking about the fact that how does frequency matter? Well, frequency matters because if I want to tip something over, frequency is incredibly important. I want to add energy to a pendulum, frequency is incredibly important. If I want to build a bridge and it has to withstand the wind, frequency is terribly important. So we know frequency is hugely important to how things affect other things. So if I'm going to draw some conclusion about wave and particle, I have to understand that, well, thinking of a photon as one continuous blob of something is wrong-headed right from the start. You've already got it wrong. You're already got a broken model.
And so forth. Again, electrons, when they were first discovered, behaved exactly like particles.
All right, so again, this exactly like thing is just so dangerous, blah, blah, blah. But clearly, yes, electrons are charged and we can count their charge. They all have the same charge. We can actually add them up, arriving somewhere, and count them because they add a certain amount of magnetism or they add a certain amount of electricity to something. We can see what they do.
Very simple. Further research show in electron diffraction experiments and so on that they make...
So electron diffraction, we're talking about reflection, so it's not really diffraction. I mean, we can use words in all these kind of funky ways, but they're really just talking about the fact that they reflect electrons off a surface. They bounce them off a surface, and because the surface is uneven, the electrons come back in a scattered form. And they'll call that diffraction. Well, they didn't really diffract. Each electron hits some kind of surface. That's why the crooked surface is there. I mean, this isn't hard to add up, right? We know we are deliberately throwing the electrons at mountains and valleys. And then we're going to say mountains and valleys didn't cause the effect. It's random. Random God's doing it. Well, then why did we make all those mountains and valleys? What the hell's the point? Why couldn't we do the same experiment without the mountains and valleys? Why do we have the mountains and valleys? What's the point? Doesn't make any sense. It's logically, there's no consistency in this logical stream of reasoning. This is a horrible trial lawyer here. He's just a shyster. He's just talking shit.
Like waves. And as time went on, there was a growing confusion in the question of how the things really behave, the way...
No, so the confusion was that there wasn't this big pile of hard evidence. We didn't have this conclusive evidence that could resolve everything for all of us. We didn't have the videotape. And that's the simple answer. There's lots of things we don't have a videotape of, and so we have to deduce them. But the whole point is that the whole point of a trial is to be careful in how you do this deducing. Be careful in what conclusions you draw. That's the obligation of a scientist, and there's no caution here. There's no careful here. There's no fairness here. I will ignore all the evidence that says you're on the wrong track, and I will just show you the evidence that proves we're on the right track. They're doing it overtly. It's clearly just propaganda.
Particles or waves, but everything looked like both. Now this growing confusion was resolved in 1925 or 26 with the advent of the correct equations for quantum mechanics.
Yeah, so he says the equation solved the issue. We figured it out because we made an equation that basically tells you something you can observe. It predicted an observation in the sense that you could have just watched it and say, okay, it's 50% this, 50% that, da, 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 da. So you make an equation that says if I know all the variables, I can know the outcome. Duh. Okay, that equation didn't resolve anything. It didn't define anything. It doesn't explain anything. It's a nothing as an answer. There's nothing in the equation that predicted anything without already knowing the answer. You have to put the answer into the equation before the equation can give you the answer out. I mean, it's that nonsensical. The equation predicts nothing that it didn't have to already know. You already have to feed it more than it's going to give you back as food. Oh, it's just so stupid.
And now we know how the particles, how the electrons and how light behave. But what can I call it? I can't say they behave like a particle wave, or they behave in typical quantum mechanical manner.
So he's going to say that they're not behaving because they're bouncing off mountains and bouncing off valleys. They're not behaving because there's a physical circumstance causing the behavior. He's going to say, no, the surfaces are not causing the diffraction. That's not what's happening. The surfaces aren't complicated. The surfaces aren't any area that can cause an electron to go this way and that way and that way and that way. All these varieties of different choices because it's a complex medium it's flying through. It's not some sort of there's only two choices, you go left, you go right. No, there's more than one choice. Okay? And that's the obvious scenario, that the light's going to scatter. It can go this way, it can go that way, go all kinds of ways.
There isn't any word for it. If I say they behave like particles, they give the wrong impression. If I say they behave like waves, they behave in their own inimitable way.
And the facts indicate they behave exactly as if they scatter off the surfaces and are just recombined at the surface. There's places where you'll put the frequency back in phase and places where you will not. And so we're right back to the jamming argument, the two-source argument. I have two sources of tomatoes, and I'm going to throw the tomatoes from the two sources at exactly the same frequency, right? You could understand that there will be places, no matter how much I mess up the tomatoes, where pieces of tomato will hit the same location back in sequence. Where there's tomato and then no tomato and then tomato and then no tomato and tomato and no tomato. And there'll be places where it won't work because the path lengths will be different. I mean, it's not that hard to logically figure this puzzle out.
Which technically could be called the quantum mechanical wave.
So again, he has to make up some new cause and effect. So it's not cause and effect. It's not a physical caused phenomenon. It's quantum mechanical wooey bullshit. It's some sort of horseshit where something that we know is a real thing travels into this simple little experiment, this slit, and somehow all of a sudden it turns into a wacky ball, and it for no good reason at all this decides to go in some stupid retarded direction. And that's what he's selling as the answer to the big puzzle, when there's really simple answers right there in front of us to pick. I mean, I would argue that you're making more sense choosing wave, okay, than to choose this idiotic answer.
They behave in a way that is like nothing that you have ever seen before.
It's up every day. Every day I see light do very predictable things and move in very straight lines and go from point A to point B in a dead straight line. Even Feynman will say this. He'll say those exact words. Photons go from point A to point B unless they hit an electron. He'll say that. And yet he'll talk this horse shit.
Your experience with things that you have seen before is inadequate, is incomplete. The behavior of things on a very tiny scale is simply different.
So again, I would argue there's no reason to believe it's different. It follows the same simple rules. It's a push universe all the way down. This momentum is in one direction. Okay, all you can do is have a lack of push. Okay, that's all there is. There is no pull. There's just a lack of push.
They do not behave just like particles. They do not behave just like waves. Atoms do not behave like weights hanging on a spring and oscillate.
Yeah, I would say that's true too. Yes, that of course they're not. Of course they don't. But they do behave just like magnets, really. If you put the electrons and the protons, just think about them being magnetically repelled and attracted. You can think of the fact that you can put them in very balanced conditions where they're attracted but they can't get closer because the repulsion from the other players is saying no, you can't go there. So I've explained all that, but you know, this can be understood with very simple mechanics. You don't have to jump into any of these woo buckets.
Or they behave like miniature representations of the solar system with little planets going around in orbit.
No, they do behave a lot like magnets, though. Again, if you just think of the charge as being magnetic, just think of it as magnets. North-south ends facing each other kind of thing, and just understand that, yes, imagine a magnetic monopole, and then just make electrons and protons at magnetic monopoles, and you can sort of figure out, yeah, I can put them in arrangements where they're stuck. They can't go anywhere. They can't go left, can't go right, can't go up, can't go down, because the tension is keeping them bound.
Or does it appear to be somewhat like a cloud or fog of some sort surrounding the nucleus?
Yeah, I'd say that's all crap. That's right. I mean, the whole spinning atom thing, the whole bullshit of the electrons, you know, it never made any sense, right? What sense does it make? You have two nucleuses here, and I'm going to stick two atoms together, and they're going to share some electron that's flying like a figure eight, or, you know, between them. Why would that glue two things together really strongly when the obvious sharing meant, oh no, they have an electron here, and this proton's attracted, and this proton's attracted, but the other electrons are repulsive, so they're caught in tension. But they're physically sharing the electron. The electron doesn't do any figure eighting. The electron is the thing that's really stationary. The atoms can be jiggling around the electron, but the electron is going to be really stuck. It's not going to have any choices.
It behaves like nothing that you've seen before. Well, there's one simplification. At least electrons behave exactly the same in this respect as photons.
So again, exactly the same. It's not the same pattern. It's clearly not on the same scales at all. It's not even close. They don't even do the experiment anyway in the same way. I mean, it's just not a fair statement.
Both screwy, but in exactly the same way.
So it's screwy in exactly the same way. Again, it's not anywhere near exactly anything. So again, this is just more exaggeration, and it's almost just too silly to argue this comparison between a photon and an electron when we know electrons are charged. They're repelling each other. Even when you're shooting them, flying them through space, they're repelling each other. There's a real force between the electrons saying they can't be too close to each other. They're going to try to spread out. That's what's going to happen, because that's their nature, is always to get further away from electrons. Electrons hate electrons forever. Even if I put two electrons at the end of 1 trillion miles, the two electrons are not going to move into each other. There's still going to be enough of a force, more force than the opposite, that's going to push them away. They're still going to be repelling each other. It's an eternal hatred that never dies and never, it diminishes, with distance, but I'm just saying it's always there. And there you have to have some other force to counter it, or they will just keep moving away from each other. It's, and I'm going to compare that to a photon. Why, that would be a stupid thing to do.
How they behave, therefore, takes a great deal of imagination to appreciate, because we're going to describe something which is different than anything.
So again, the imagination isn't trying to make something up. The imagination is trying to capture the reality. You're trying to draw it in some kind of simplified way where you can understand what might be causing the effect. What could cause a photon to move in a new direction? Well, we already know that electrons are fantastic at that. And what's on the surface of materials? Oh yeah, electrons. They're always there. Even when something is positively charged, there's still a bunch of electrons on the surface.
You know about this, in that respect at least, makes this perhaps the most difficult lecture of the series, in the sense that it's abstract, in the sense that it is not close to experience.
So, and why? For what reason? Why aren't we trying to confine it to what we know to exist in the world, where, you know, stuff falls down off a mountain and hits rocks and stuff happens? You know, every single physical thing we see, nothing do we have any expectation that there's any piece of an avalanche, for example, right? We don't think any piece of that avalanche is disobeying cause and effect mechanical rules. We don't sit there and say one piece is going extra fast. We don't have any delusions like that. So why are we allowing those delusions to enter this diagram?
And I cannot avoid that. Were I to give a series of lectures on the character of physical law and to leave out from this series the description of the actual behavior of particles on a small scale.
So let's understand. Okay, he's going to say this is the actual behavior. It's not the actual behavior. First off, he can't, to save his life, describe the experiment accurately. And he's assuming a whole bunch of conditions that have been tested that were never tested. And so it's just, it doesn't have any basis in reality, in some sense. I mean, it's so far from actually recognizing what the experiment does show.
Yeah, I would certainly not be doing the job, because this thing is completely characteristic of all of the particles in nature and as a unit.
So I guess, and he says it's characteristic of all the particles, blah, 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 blah. They have no evidence of that. It's just a preposterous exaggeration of the reality. What we do know is that surfaces always affect things, and they affect some things more than others, and that's the truth. A surface, a change in medium, is a change in medium. Transitions from one medium to another affect everything that has to go through the transition. So it's always going to mean something. It's always going to have an effect. How much effect is the question?
Universal character. And it is, if you want to hear about the character of physical law, essential to talk about this particular aspect.
It really isn't. It's not essential at all. You could keep it just as simple as it actually is.
So it will be difficult. But the difficulty really is psychological and exists in the perpetual torment that results from your saying to yourself, but how can it be like that?
Why would I believe it's like that? With so little evidence, you're not going to provide me any evidence, every good reason to believe, except you're going to say, I can't think of any explanation that works. Because I keep drawing it wrong. I keep thinking a photon is a bowling ball. Well, no, it's not really a bowling ball. I mean, it could be round, the quanta in the photon, but the fact is the photon is a pattern. A pattern is produced by, a radio wave. A pattern is produced by all these things. Patterns are produced. Pattern, sequence of events is what's being produced. And that's what you have to receive. You have to receive something that comes over time. Everybody knows a radio wave isn't, I just take one hunk of radiation hits me. There, radio wave. It's 500 megahertz. No, I have to wait for another one to show up, or I don't know what megahertz it is. I don't know what it is until the second one shows up to tell me what it is. At least two. So, this is just such bullshit that we can receive one piece of energy, bang, and that's Morse code. Okay, that somehow by just going tap, dot dash, no dashes, just dots, and no dots, between time. No, just one dot. There, I said something. You can't say something with one dot. And radiation doesn't say anything with one dot. It's not how it works either. The photon is not a dot. It's a dot dash at a certain frequency.
Which really is a reflection of an uncontrolled, but I say utterly vain, desire to see it in terms of some analogy with something familiar. I will not describe it in terms of an analogy with something familiar.
Except waves. You will do that. Okay? So, to some extent. All right. He relies on that. He already did in this. You saw that part. So he already made the statement. So he's already using an analogy. But yes, he really doesn't believe it's a wave. He says overtly in 15 years after this lecture, he says overtly, I wish they didn't teach that that photons were waves. Because they can't be. Because he's proposing a third theory, that there's a magic random God. The random God makes things do wacky stuff. That's his proposal. Wacky is just part of it. It doesn't have to hit a mountain, doesn't have to hit a valley, doesn't have to interact with a surface, doesn't have to have a cause for the wacky. The wacky just happens. That's his theory. And I'm arguing there's absolutely no reason for you to believe that. No good reason. No good evidence demonstrating it. It's all hype and bullshit. Oh, it's so mysterious. No, it isn't so mysterious. Oh, it can't be. Yes, it can be explained.
I'll simply describe it. There was a time when the newspaper said that only 12 men understood the theory of relativity. I don't believe there ever was such a time. There might have been a time when only one man did, because he's the only guy who caught on before he wrote his paper.
Yeah, what's to understand? So that's another big fat pile of crap shoved on the human race. Einstein had no clue how to make it work, okay? And he was forced to create his field equations because, Eddington asked him to. Said, "What can you explain Mercury's precession?" And so he spent a few months contriving wacky math to make it work. When the simple explanation I could offer you is, all I have to do is create a mathematical precession of the sun. If I just make the center of the sun's mass, you won't even be able to see it. It's such a small precession. But I just say the center of the sun's mass is precessing, it moving, constantly circulating. I just create that little bit of noise, and Mercury will feel it and the Earth won't. And that's the truth. It'll completely affect Mercury's orbit. It won't affect the Earth's orbit. It's too far away. So I can use something that simple, that mechanical, as an explanation. Or you can believe the woo. I mean, it's your decision. I can only reason with you. Okay? You want to just go with the unreasonable explanations, that's your prerogative. But I'm going to call it what it is, religion. You're not doing it because that's where the evidence points. You're doing it because, it's so much more interesting or something. Some sort of crap like that. It's such a great way to evade reality. Is just make up these fables, these silly little stories to live by. This gingerbread crap, this Wizard of Oz bullshit.
But after people read the paper, a lot of people kind of understood the theory of relativity in some way or other. But more than...
Yeah, there's no way to understand it because it's not an explanation. The magical blank makes stuff move. Electrons and protons are minding their own business. All of a sudden I create a gravitational field and it's not made of anything. It doesn't do anything. They just somehow know, I have to go that way. Oh, okay, I have to go that way. Because the field of blank says so. Great answer. I mean, I totally understand that. Nothing telling something what to do? Sure, that makes sense. Shit.
12. On the other hand, I think I can safely say that nobody understands quantum mechanics.
So, that's supposed to be a joke. It's not funny. I mean, it's really not funny that you're sitting here duping a whole audience into thinking it's smart to be this fucking stupid. Good. Yeah, I'm totally proven that, that, nothing makes something, Why put mountains and valleys on the surface? No, just let the nothing do it. So much easier.
Now, if you appreciate this and don't take the lecture too seriously, that you really have to understand in terms of some model what I'm going to describe. And just relax and enjoy it. I'm going to tell you what nature behaves like, and if you will simply admit that maybe she does behave like this, you will find her a delightful, entrancing thing. So that...
I don't know why I would do any of that. Why would I find it delightful and entrancing to imagine particles that don't do anything coherent or rational? They're just irrational. So the whole foundation of our existence is based on some sort of bizarre randomness that doesn't make any sense, that doesn't improve anything, doesn't make anything smarter, doesn't make anything work better, doesn't do a goddamn thing, and it's completely inert in terms of it's on such a tiny scale. The only place any of this happens, any of this magical randomness, this fake randomness, just for what purpose? Just to believe in fairies. So he's basically saying, just imagine I'm telling you the truth, and there really are angels, and they're pushing the earth, and it's okay, it's fun. Whatever. Maybe for you, gives me the creeps.
That's the way to look at the lectures, not to try to understand. Well,
no, don't try to understand. Well, you have to understand. Well, don't understand that you're not understanding. That's fun. Shit.
understanding English, of course. But in any sense, in terms of something else, don't keep saying to yourself, if you can possibly avoid it, but how can it be like that? Because you'll get down a drain, you'll get down into a blind alley in which nobody has yet escaped. Nobody knows.
Right. So nobody can do it. So nobody can do it. So nobody can do it. Nobody can do it. Nobody can do it. No one can do it. We can only think bowling ball, bowling ball, bowling ball. Can't think anything else. It has to be a bowling ball. Radio waves are bowling ball. Everything's bowling ball. I'm just saying they're so. It's so easy to imagine other mechanisms. It's so easy.
Knows how it can be like that. So
It's so easy to imagine school of fish and say, hey, the school of fish is kind of complicated, right? There's fish going this way and fish going that way and fish going all kinds of different ways. And the whole school, though, is moving 2 miles an hour this way. So in net, there must be fish going that way a little bit more than fish going that way and fish going that way and fish going that way. Somehow there must be more fish that are causing the school of fish to move in that direction. So even though it looks like chaos, it's not really chaos because there's clearly more fish going one way than are going all these other ways. Not hard to dissect. Don't have to believe in magic.
then just let me describe to you the behavior of electrons or of photons in their typical quantum mechanical way. So the way I'm going to do this is by a mixture of analogy and contrast. If I made a pure analogy, we would fail. So it must be by analogy and contrast.
Well, I don't know why you have to do any of that at all. You could just draw the real experiment. Just say, look, the light experiment is dirt simple, and that's what I'll show you is the light experiment. I won't switch it to electrons and then switch it to buckyballs and then Sherman tanks. No, I'll stick to one subject and show you how this is a really solid proof. But no, he doesn't do that.
The things that you're familiar with. And so I make it by analogy and contrast first to the behavior of particles, for which I will use bullets, and second to the behavior of waves, for which I will use, say, water waves or sound waves.
Right, and the contrast is ludicrous because the bullets, he's not giving the bullets a frequency going in. So they don't have a frequency of any kind. So he's taking away one of the major components. The components we know are invaluable to getting the calculations correct. You can't do the math without the frequency. And he's essentially taking frequency out of the equation for bullets. He's going to describe a circumstance. Doesn't have anything to do with the reality. Doesn't have anything to do with what bullets do and how bullets would react. And again, the real question is whether, we have any reason to believe that it isn't about a pattern going into a process, the pattern being broken, and then the pattern being recreated, when that's the easiest and simplest explanation.
So we begin first to discuss in a particular, what I'm going to do is I'm going to invent a particular experiment and first tell how it would behave, what the situation would be in that experiment using particles, what you would expect to happen if the waves were involved, and then what happens when there are actually electrons or photons in the system. And I will just take this one experiment which has been designed to contain all of the mystery of quantum mechanics, to put you up against the paradoxes and mysteries and peculiarities of nature 100%.
Right, that would be great if he really did that, but he doesn't, right? He's not going to make the fair comparison between water, but he's not going to show us the single slit in water and demonstrate clearly there's no interference pattern. Doesn't fit at all. Bad analogy, doesn't work, fails entirely. He won't even do the double slit in water with two waves because, frankly, two waves doesn't get the right answer. Wrong mathematics, wrong geometry, fails again. And then he's going to do a bullet example where he takes away all of the qualities that the particles would have, which is they'd have a frequency and they would be deflected by the surface. So if you have bullets that come at a specific frequency and that they reflect off the surface, the bullet analogy works just fine. Does all the right geometrics, does all the right things, answers the question completely. It's just you can't make the rules stupid. You have to make the rules realistic to what a photon is, not a bullet. You have to give the bullet some fair properties that are something in common with photons, not nothing in common with photons.
Any other situation?
I'm just pointing out the analogies are so unfairly displayed that this is where you see the propaganda. It's so unfair and so biased, and that's just, it's evidence of that they have a bad argument, that they have to cheat the truth so much. They cheat the truth so much, just demonstrates that they're desperate. That this isn't something they understand. It's just something they are forcing to be the truth. They're not allowing it to be the truth. They're forcing it to be the truth.
Quantum mechanics, it turns out, can always be explained afterwards by saying, you remember the case of the experiment with the two holes? It's the same thing. And so I'm going to tell you about the experiment with...
So again, the same thing is just so dangerous to sit there and say everything's functioning. You know, airplanes fly by the same principle a bird flies or a bumblebee flies, or everything flies for the same reason. It's not the same.
The two holes, which is the general mystery, does contain the general mystery. I am avoiding nothing. I am bearing nature in her most elegant and difficult form.
Okay, so the truth is he's not bearing nature in any honest way. Okay, it's just going to be a dishonest portrayal of the model. He's going to show the two models in distorted fashion and not give the truth any hope.
So I start with bullets. And all the experiments are going to be in the same general design, so I'll draw it this way. Suppose that we have some source of bullets, which is just represent the source, which we call the source, and is in fact, in the case of bullets, a machine gun. Then we have a plate in front here with a hole in it for the bullets to come out of, and this plate, in the case of bullets, is armor plate. Then a long distance from here, we have another plate, which I'm drawing only a short distance because I haven't got room on the blackboard for everything, but this distance is supposed...
So again, he's putting into the experiment what, you know, frankly, nobody in the modern era needs, which is the culminator. This first, he put this through a single slit, so you're increasing your odds of having light that's flying parallel. So it's not spreading as much because you're far enough away from it and you're shining light, and the photons that are going through are mostly not spreading. They have a very small degree of spread because they've made it all the way to the surface without spreading very much. So you've gotten rid of the scattery kind of light, and you have light that's moving fairly parallel. Now the problem is the surface of the slit is going to create some fringes, but those fringes are going to be so minor, they're a small percentage of the total amount of the beam, that they're not going to be an issue, and they're going to be so far outside of the two slits that they're not even going to be able to get through the two slits. So that's not going to be a problem. But, you know, he doesn't explain the purpose of that. And so, again, that's superfluous to any modern interpretation of the experiment. You don't need to do that.
To be much longer in proportion to the width. Please expand that. That's a small point. And it has two holes in it. That's the famous two-hole business. I'm going to talk a lot about these holes. So I'll talk about this.
Right, so he drew them very nice and straight and parallel, but, you know, the alignment was horrible. But whatever. I mean, that's a small, minor issue.
Hole is number one hole, and the other hole is number two. And I'm only drawing it in two dimensions. You can, if you wish to imagine these as round holes in three dimensions, but just say it's a cross-section. And then again a long distance away, but we'll go...
Gets terribly confusing to do the two aperture pattern in round, you know, Newton's rings round, because now you're overlapping round patterns, and so now you have to consider only the ones that overlap, and it's a lot more complicated.
Relatively short distance because of the limitations of this blackboard. We have another screen here, which is just a backstop of some sort, on which we can put in various places what I will call a detector. And we'll mark that detector.
So let's understand that what started this whole thing is the Young experiment, right? That's the famous part of it. And so this really isn't about running detectors across the screen and collecting things and doing all this crap. It's about just looking at the surface. And obviously with bullets or lights, you'd see the same thing. I mean, either bullets are hitting the target or they're not hitting the target. Either they're spreading or they're not spreading. See, we don't need to do this detector crap. This is only necessary when you're being so fine in what you're detecting. Like if you're going to use a photo multiplier, you can't see a pattern with a photo multiplier. All you can do is count photons. So to see the pattern, you'd have to test at different locations with a photo multiplier. So depending on the tool you're using. But clearly with the two-slit experiment in light, you can see the pattern. It's just, all this is unnecessary.
Which in the case of the bullets is a box of sand into which the bullets will be caught, and we can count them. That's the detector for bullets. I don't want to have to redraw the experiment each time, so I'll label everything in this way, and then we'll be able to catch on to situations for different cases. And also, I'm going to do experiments in which I count how many bullets come into this detector or box of sand when the box is here, or here, or here, or here. And to describe that, I'll measure the distance of the box from somewhere down here and call that X. And I talk about what happens when we change X. It means only you move the doggone thing up and down. All right.
Right. So this is a complication again. Like I said, just really, this was just to create confusion because it's really so unnecessary to understanding. But I guess he wanted to make it so he could talk about single bullets at a time and measuring them.
Now, first, I would like to make a few modifications from real bullets into idealizations. The first is that the machine gun is very shaky and wobbly, and that the bullets going very...
So again, this is essential to this whole argument of Heisenberg and the rest of it, that if we, someday are actually to make a very fine laser beam, that is a very small beam that we can shoot through one hole or the other hole only, that, then we'll know what slit the light goes through, kind of obviously, then this whole thing is moot, right? Because then we know, what slit the light went through. And the question will be is if we can move it back and forth quickly enough, to give there to be an opportunity for the path length differences to add up. I mean, clearly light has to be at all of the surfaces for something to happen at the target. To remake a photon, you basically have to have parts coming from all the surfaces. And so if this other, so one surface isn't producing parts, it can't possibly create parts that can be recombined. So you can't possibly have path length differences from that location and make any contributions to remaking photons. You can't do it. Duh. Yes, there's no pattern if you're only shooting bullets through one slit. You're not going to get the double slit pattern because you've eliminated two sources. Clearly, obviously.
Various directions, not just exactly straight on, in fact. And they can ricochet off the edges of the the holes in these armor plates. And finally...
They can, he said. So here he says they can ricochet. But no, they can't.
Well, let's say, for instance, that the bullets have all the same speed or energy if you want, but that's not very important. But
it sort of is very important. Obviously, the whole thing is dependent on path length differences. So obviously, if you think the bullet slowed down, that's going to change the path length difference argument, dramatically slowed down. Yeah, I mean, if it slows down a little tiny bit, that's not going to matter. But it's going to matter if it slows down a lot.
The most important idealization in which it differs from real bullets is I want these bullets to be absolutely indestructible. So that what we find in the box is not pieces of lead of some bullet that's broken half. And we get the whole bullet, please. So imagine indestructible bullets, or hard bullets and soft armor plate or something.
Right, so that's another condition he places on it that just messes the whole thing up, right? Because you're really collecting a pattern. You're not collecting a single bullet. So it sort of defeats the whole argument about what a photon is in the first place. So if you think a photon is just a single bullet, and if you think the wave function is a single wave, doesn't have to be the waves keep coming, and you're seeing the wave frequency based on more than one wave coming. If you don't understand that that's really what has to happen, just like a microwave receiver, any kind of receiver has to see more than one wave to know what the wavelength is. If you don't think so, well, I'm saying you got something wrong. You don't understand how it really works. You can't do it with particles or waves without there being wavelets or particlets. You have to understand it's a pattern that arrives. It's not one wave.
And now the first thing that we will notice about bullets is that the things that arrive come in lumps. When the energy comes, it's all in one bullet full of bang.
Yeah, well, it's always a photon or not a photon. So, but that's the whole question. What is a photon? Again, if you think it's one wave, I don't need all the other waves. I just need one. There, one wavefront. So I can have one ocean wave, and from that one ocean wave, I can tell what all the rest of the frequencies are and everything. If you think that's the way it happens, okay, you can think that way, but I'm saying, well, no, I would argue that that's not getting it right, that a photon is a pattern. So yes, the pattern either is or it is not. You either made a frequency like ... You need 4 of them, let's say. We could say 3, whatever the number is. You have to have all 3. If you don't have all 3, you have 2 dots, it's not enough. It's not a photon. You can have 5 dots, but if they're wrong frequency, that's not a photon. A photon is dot, dot, dot. In that order, at that speed. If you don't get that, it's not a photon. That's the function. That would be the fair to include as a possibility here. And he's ignoring that possibility.
If you count the bullets, there's 1, 2, 3, 4 bullets. The things come in lumps. They're equal in size, we suppose, in this case. And when a thing comes into the box, it's either all in the box or it's not in the box.
Now, the question is, it either moves an electron or it doesn't move an electron, and you have to move it a certain amount to cause electricity. So we can only measure a photon when it stimulates an electron a certain amount. If it stimulates it too little, it doesn't mean anything. We didn't see it. It didn't happen. It has to hit with the right frequency. It has to add energy to the system. It has to hit the pendulum when it's swinging away, so it goes faster and faster and then flies off. It has to tip the electron. And it can wobble electrons, but that's not tipping. So, it's dependent on hitting it more than once in a certain amount of time. And that's what causes what we say is a photon. And if it doesn't cause that momentum, if it doesn't make the electron move fast enough, there's no photon.
It comes in lumps. More. If I put up 2 boxes here, I never get 2 bullets in the boxes at the same time. Well, if the gun isn't going off too fast and I have enough time between, slow down the gun so they go off very slowly. Bing, 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 bing.
And what's going off, just understand, what's going off isn't just one wave front hitting, okay? Bing happens when 3 waves hit the shore and we see the frequency and it's the right frequency. That's a bing. 3 waves, bing. 3 waves, bing. 2 waves, no bing.
Put the 2 things here and look very quickly in the 2 boxes. You'll never get 2 bullets at the same time in the 2 boxes because the bullet is a single identifiable lump. I call that characteristic of the object that it comes in lumps.
Well, the truth is we detect it in lumps. So that's the simple explanation for why it comes in lumps, because we only have lump detectors. There's no other way to detect a photon. The only way you detect it is it has to cause an electric current. And causing an electric current requires more than one event. And that's the simple explanation.
So the first thing about bullets is that they come in lumps. And now what I'm going to measure is how many bullets arrive here on average in a long period of time. So you wait an hour and you count how many bullets are in the can, in the sand, and average that. Now, we call that, if you want, let's say we take a definite time like per hour and say the number of bullets that arrive per hour. And sometimes you could call that what's called the probability of arrival, because it just gives the chance that a bullet going through this thing arrives in this particular box. At least it's proportional to the chance. One way to measure is to measure the average number of bullets that arrive over a period of time.
In each location. And then he's finally going to draw, eventually he's going to draw his lump pattern. And then he's going to commit the preposterous error of presuming that somehow the lump patterns are separating with distance, that they're getting further and further and further apart from the 2 holes, when that's not actually happening at all. That's not part of the experiment at all.
Now the number of bullets that arrive in this box here will vary as I vary x. And I'm going to make a graph here in which I plot horizontally the number of bullets that I get if I hold this thing here for an hour. And I'll get a curve that will probably look more or less like this. Because when the box is behind one of these holes, it gets a lot of bullets. The ones that went through this hole.
Right. Okay, so in the photon experiment, obviously these 2 holes are a number of mere wavelengths apart. The whole experiment is a millimeter across. So it's a tiny amount of distance between the 2. And the whole point is the light going through the holes isn't getting bent. Only the light on the surfaces is getting affected. And the 2 patterns are going to fly through space a millimeter apart from each other. The light that goes through the center and doesn't get bent is obviously that light's going to keep going through the center. And when it hits the target, it's still only going to be a millimeter apart. And so the 2 humps are going to be just a millimeter apart from each other. They're not going to be spread apart in any distance at all. They're going to be a tiny distance difference. tiny, so tiny you wouldn't see it at 10 meters away, or even 3 meters away. You wouldn't be able to measure the difference. It's such a small amount of difference. So this is another huge perversion of the truth. The fact is, the one mountain created by one of the openings would be almost exactly where the other mountain would be. They'd be right on top of each other. They would look to your human eye. If I turned one on, closed one, opened the other, you wouldn't be able to tell that they were actually in a different place. They're going to be so close to each other, so close to exactly the same place. So this is just distortion and perversion, to confuse, to misdirect.
And otherwise it gets in the one through this hole, and if it's a little bit out of line, it doesn't get as many. They have to bounce a little off the edges of the hole, and so it disappears like this. And this is the number that we get in an hour when both holes are open. And I call that, by an abbreviation, N12, which merely means the number which arrive when hole number 1 and hole number 2 are both open. Looks like that, sir.
All right, so I mean, right there we got him. Bullshit. That's not what it's going to look like. That's nonsense, rubbish, garbage. Electrons won't do that. Protons won't do that. Photons won't do that. Nothing will do that. So it's not part of any real discussion. Real bullets wouldn't do that. You can understand, the bullet that goes straight through and the bullet that goes straight through are still going to be exactly the same distance apart from each other. And then the side patterns from both of those slits are going to be also proportional and the same. And so you just measure the distance between the two parallel ones, and that's the distance that all the scatter will be the same distance too. And all you're going to have is the distance between the two openings. And in the case of a photon experiment, that's a tiny, 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 tiny difference. Mere, like I said, a portion of a millimeter. And you're not going to see a portion of a millimeter difference at, when the pattern is blown up, projected at a foot and a half. You're not going to be able to see in a foot and a half a millimeter of difference. All right, so that's probably a good enough place to end. Maybe we'll do the rest of this in the future. I don't know. I mean, I've done it already. We've already been through this. We've been there and done that. I've done a 17-minute video that points out all of this garbage and nonsense and explains how the whole pattern can be understood as a simple mechanical process. It requires absolutely almost no imagination. The facts are so simple. Photons are scattered by electrons. Lots of electrons in the surfaces. The photons that travel near the surfaces get scattered more. The fact if I make the surface smaller and smaller, I'm increasing the likelihood that the photon is going to interact with the surface, making it more possible for the pieces to be scattered off. And all you're saying is how many photons can I remake? When can I put the pattern back in sequence? And that's it. You take them out of sequence by changing their path length. You can put them back in sequence, okay, by just changing the order of what pieces you're using from which surface. You can use the number 3 piece to be the first piece on one surface, and the number 4 piece to be the third piece on the other surface. Doesn't matter. You're just putting the pieces back into the same ... order. It's that simple. No woo required, no Heisenberg, no entanglement, no superposition, no random God. None of it is necessary. So, enough of a video. So, anyway, guess I'll just title it something like Dermot's a jerk, because that's what else is there to say? I mean, I made every effort to be polite, considerate, to give him every advantage in the conversation, to allow him to know exactly what I was going to ask about and what questions I would pose. And there's just complete unresponsive nonsense in return. Just amazing. Amazing evasion.